Dear students, in this video lecture, we are going to see about the nonlinear equalizers. Before entering into the nonlinear equalizers, let us discuss what are the disadvantages of the linear equalizers. The linear equalizers cannot be used when the channel distortion is severe. When the distortion is more in the spectrum of the passband, these linear equalizers do not perform well. To compensate with the distortion, the linear equalizers place too much gain in the frequency range of the distortion. So the linear equalizers not only enhances the original signal but also enhances the noise in the same spectrum. To avoid the disadvantages of the linear equalizers, the nonlinear equalizers are used. There are three effective methods in nonlinear equalization: decision feedback equalization, maximum likelihood symbol detection, and maximum likelihood sequence estimation. Out of these three methods, in our syllabus we have only decision feedback equalization and maximum likelihood sequence estimation. Let us see these nonlinear equalization techniques one by one. First, the decision feedback equalization. In this technique, once the information symbol is detected, the inter-symbol interference on future symbols are estimated and subtracted out before the subsequent symbols are detected. The decision feedback equalizers can be realized either in direct transversal form or lattice form. This is the structure of direct transversal form. This structure has feed-forward filter and feedback filter. This feedback filter is driven by the output of the decision maker, which is also known as the detector. Based on the output of the detector, the filter coefficients of feedback filter are adjusted in order to cancel the inter-symbol interference. The output of the equalizer decay cap is the sum of the output of feed-forward filter and the output of a feedback filter. This is given here. The first term is the corresponding to the output of feed-forward filter and the second term is corresponding to the output of feedback filter. The output of feed-forward filter is the sum of the products between the filter coefficients in the feed-forward filter and the input to the feed-forward filter. The output of the feedback filter is the sum of the products of the tap gain in the feedback filter and the input to the feedback filter. This is the expression for the minimum mean square error for a decision feedback equalizer. The decision feedback equalizer has significantly less mean square error than linear transversal equalizer. So the decision feedback equalizer is better than linear transversal equalizer with respect to the mean square error. The linear transversal equalizer performs well when there is less distortion in the channel. If the channel is severely distorted, then the decision feedback equalizers can be used. The decision feedback equalizer can also be realized in lattice form with feed forward length as N1 and feed backward length as N2. In the lattice structure, the feed forward length should be greater than the feed backward length. The another form of decision feedback equalizer is predictive decision feedback equalizer. This is the diagram of the predictive decision feedback equalizer. This structure has a feed forward filter and a feedback filter. This feedback filter is driven by the difference between the output of the detector and the output of the feed forward filter. This feedback filter is called a noise predictor as it predicts the noise and the remaining inter-symbol interference at the output of the feed-forward filter. The feedback filter in the predictive decision feedback equalizer can also be realized as in the lattice form, where the RLS lattice algorithm can be used to yield the fast convergence. The next nonlinear equalizer is the maximum likelihood sequence estimation equalizer. Generally, the mean square error based linear equalizers are the optimal equalizers when there is minimum probability of symbol error. When there is more symbol error, The MLSE equalizer can be used at this situation. The MLSE equalizer tests all the possible data sequences and chooses the data sequence with maximum probability as the output. For choosing the data sequence with maximum probability, the MLSE equalizer uses the Viterbi algorithm. The Viterbi algorithm is a dynamic programming algorithm used to find out the maximum likelihood data from the hidden data set. This is the diagram of MLSE equalizer. The matched filter acts as the feed forward filter. The channel estimator acts as the feedback filter. The channel estimator is used to track the change in the behavior of the channel by comparing the current output and the previous outputs coming from the decision maker. Here MLSE acts as the decision maker. Based on the change in the behavior of the channel as estimated by the channel estimator, the matched filter will adjust its filter coefficients and will try to give the output which is approximately equivalent to the input. The MLSE will verify all the data sequences coming from the matched filter and chooses the data sequence with maximum probability as the output. There is only one drawback in this MLSE equalizer is that there is a large computational requirement when the delay spread of the channel is large. That's all about the nonlinear equalizers.